My name is Ryan Morrow, and this is my Week 6 assignment for Introduction to Ammunition and Basic Ballistics at Sonoran Desert Institute. Today is Saturday, October 11th, 2025. For this week's assignment, I'm going to be using everyday objects to try to explain a handful of terms that are used in ballistics. So the first term we've got here is trajectory and sights. According to Oxford Languages, trajectory is the path followed by a projectile flying or an object moving under the action of given forces. So a bullet's trajectory is its flight path after having left the muzzle of a barrel. So typical sights on a firearm will often feature a front post or dot or bead with a rear aperture often shaped like a notch or a V shape or sometimes a ring or a small hole. So next is gyroscopic drift, which is sometimes known as spin drift. It's defined as deviation of a bullet from its intended trajectory due to the gyroscopic forces generated by the bullet's spin. So in a nutshell, it's saying that gyroscopic drift is the bullet unintentionally changing its path because of the spin put on it by the rifling. According to NASA's Glenn Research Center, drag is the aerodynamic force that opposes something's motion through the air. In ballistics, bullet drag refers to how much resistance is being imparted on a bullet during its flight. Hornady's blog has a lot of good information about bullet drag, and a good takeaway from their research is the greater a bullet's drag, the longer it takes to get to its target. According to Encyclopedia Britannica, the Magnus effect is a generation of a sideways force on a spinning cylindrical or spherical solid immersed in a liquid or gas when there is relative motion between the spinning body and the fluid. Next, we have the theories of the Coriolis and Oathus effects. Essentially, the Coriolis effect suggests that your position relative to the Earth's equator may have horizontal and vertical effects on the bullet's trajectory. Whereas the theory of the Oathus effect suggests that vertical deflection can be caused by the rotation of the Earth. These theories are very hard to showcase with everyday objects, as it's suggested they mainly affect long-range distance shooting. Nevertheless, to show off the so-called Coriolis effect, here is the same parlor trick that everyone is familiar with from elementary school science class. Next, we have vertical angles, which in ballistics is pretty key in accurate long-range shooting as well as indirect fire. Here is a simple schematic I found that sort of explains it. So lastly, we have transonic ballistic performance. And according to AccurateShooter.com, the transonic ballistic effect is what happens when a bullet slows to transonic speed, close to the speed of sound and the sound barrier, around Mach 1, and it's sort of apparently a bad speed zone to fly anything in. This zone can definitely have an effect on ballistic performance and accuracy, but evidently it has been overcome with faster barrel twist rates. It's basically impossible for me to capture and showcase the transonic effects on a bullet for this video's sake. Here is at least a showcase of either side of this transonic zone, subsonic and supersonic. Here I've got two different types of CCI 22 ammo. First are some stingers, which are going just under 1,700 feet per second at the muzzle. And then I've got some 22 quiets, which are subsonic and only pushing just over 700 feet per second at the muzzle. For this week's assignment, my sources included Nigel Evans's British Artillery Fire Control Ballistics and Data, Nancy Hall's What is Drag, William Hausch's Magnus Effect, Brian Litz's Modern Advancements in Long-Range Shooting, Volume 1, Harry Palmer's What is Spin Drift definition. Understanding drag holds key to better solutions from Hornady Manufacturing, and Ballistic App Tips, the Coriolis effect from Lapua.